Our next speaker will be Shamia Kashyap. So Samia will be talking about building Flutter apps with building blockchain apps with Flutter. So Shamia is a blockchain developer fellow at Celo. He will showcase a demo that showcase a demo of file uploads to interplanetary file storage and write a test net that can be deployed to Ethereum. So welcome, Shamia.
Hi,
Hi,
here.
Anna.
How are you
Thank you so
doing?
much.
How is
Yeah,
your
I'm fine.
mood
How about you?
today?
I'm sorry.
Great. How is your mood today? Are you ready to
Yeah,
present?
it's been great. Yes, I'm all ready.
Great. Do you start to share your presentation? And we will
Okay.
add it to the screen. Yes, but start to share. Great. Yep. Great. So the
Okay.
stage is yours now. Take your
Thank
time. Have a good presentation.
Okay, thank you, Anna. Hello, everyone. I'm Samir from Bangalore, India. And today I'll be talking about building blockchain apps with Flutter. So I'm currently in my final year undergrad. I'm about to graduate. And I am currently a fellow under the fellowship called Celo India Fellow, where I'm helping the Celo blockchain transition, like writing the Dart SDK so that all the Flutter community members can build blockchain apps on the Celo blockchain. So great to have you all here, and thanks for this opportunity. So let's just get started, right? So we must have all seen like how blockchain is like trending right now in the recent years, right? Especially this year, I think it has seen a massive boom, and cryptocurrencies are like at all-time high, and everybody's buying crypto, and there's so much buzz around it. But let's just understand that blockchain is not just about cryptocurrencies. It's so much more, and it helps us solve the fundamental issues we are facing with data privacy. And let us, as I go on, I'll tell more about what the features of blockchain are and how you can deploy Flutter apps on blockchain and what's the benefits and everything. So let's just dive into it and understand what blockchain is and why is it helpful, right? So to put it in a definition in my own words, I would say blockchain is a network of secure, distributed, and decentralized nodes. It stores a history of transactions on a public ledger, and it is immutable to changes. So this is what makes blockchain usable as a digital currency, because it stores transactions just like how a bank would store it or a ledger would store it, right? And it's also immutable to changes, meaning that nobody can tamper with the blockchain and change its data. So let's take a look at a single block and what does it have. So each block in a blockchain contains three main components. The first is the hash. This hash is uniquely generated based on the data that is inside the blockchain. And the second part is the data, which is the data itself. For an example, in a Bitcoin blockchain, this data would be the address of a sender and a receiver and how much Bitcoin was sent to from one person to another person, right? So this is how this is the data that is stored, and based on this data, there is a hash that is generated, which is a cryptographic hash and is very unique, and it can't be duplicated or replicated. Then the another feature is that each block also contains a previous the link to the previous hash, meaning that a block that has the previous hash will be linked to that previous block. This is what makes blockchain so secure that in terms how it would look, just like I showed in the diagram, that it is just a list of nodes. And what makes it secure is that each block is connected to each other. And if a person tries to tamper with one block, that data will change and so will the hash. So now that the block that was connected that contained the previous hash realizes that this block is no longer valid because I have a different hash. And that is how that entire blockchain will be invalidated. And then that's how the blockchain can never be tampered with. So this is not the only way that blockchains are like secure. There's another advantage or another feature of blockchain, which is decentralization, meaning that in our typical services that we use, like cloud or whatever applications we're using, all of them are centralized, meaning that we are putting our trust in one entity to make sure that they store our data in one single place, right? But that's not how blockchain works. So in the case of blockchain, all of the data is stored on multiple computers. So each node on the network will have a copy of the blockchain. This is what makes it so hard to change data on every single node. And this is what makes it really good to use because of the decentralized feature. So how does this actually work? So every time a person makes some data call or something to the blockchain to add new data, there needs to be some kind of condition so that people don't relentlessly add data, right? So this is what is done by an algorithm called proof of work, which is also different in multiple blockchains, but this was the core which Bitcoin and Ethereum both use. So proof of work is simply an algorithm which helps assign and validate the data that was added. So how this works is each node participating in a blockchain can try to and participate over a complex computation algorithm, a problem, complex computation problem. So this problem should be solved by the participant, and whoever solves it will uh, be able to sign the transaction. So that's why it's called proof of work, meaning that you have to do work to validate the transaction. And whichever node makes that transaction, validates the transaction, will receive some incentives as a part of using their computation power to make this transaction happen, right? So that's how once a node makes that sign, every node or most of the nodes in the network will agree that this node has added the right block, and they'll all reach consensus, meaning that they'll all agree and they'll update their own blockchains to add this new data. And that's why it is so tamper-proof that each node has to have that validated and updated blockchain. And if only one block or one node in the network has a separate different block, it can easily be identified that this block does not belong to this blockchain and it is tampered with. That's how nodes reach consensus in the blockchain. And after all this, like the new block is added, right? So let's check out why should you care about all of this, and why should you actually know about blockchain or try to get into it. So these are some of the greatest features or advantages that blockchain gives. One is that it's transparent, meaning all blockchain transactions are public and they are not hidden behind anything. Although no public information is disclosed, each public key and the transaction and the amount of gas that was used, that is disclosed on all blockchains. All are public. They're secure, like I mentioned. Most of them are open source, meaning you can check out the code of the blockchain. 100% uptime, because all the data is available on different computers. So you're not just relying on one endpoint or one cloud, one part of the node where you need to access the data. So some blockchains are always up, like they're never down like a server, and they're accessible. So a lot of blockchains follow some governance protocols, meaning that the user can select what features they want in the blockchain, and these kind of protocols are around. And it is trustless, meaning that we don't have to trust. The code is the trust, meaning that a blockchain or the blockchain code will do exactly what it says and will never maliciously try to do something else. This is how cryptocurrency works, meaning that we don't need a third party such as a bank to put our trust in. We can just trust the system, which will do what it says. And that's why we're able to trade coins, right? So let's see how can we exactly accomplish this, especially in Flutter. So the first thing that brought about a revolution in deploying or developing apps was not Bitcoin, it was actually Ethereum. So Bitcoin, although is a blockchain, it can only make money transactions. It can't actually deploy applications. So Ethereum took this idea further, and they made a blockchain that could actually run code on it. So Ethereum is not just a blockchain, it is also a state machine, meaning that it can run arbitrary code on it, just like how you'd run it on a computer. And how Ethereum does this is something called the EVM. EVM is nothing but the Ethereum virtual machine, which is the tool that runs Ethereum code on it. And since everything is decentralized and there's no central processing to bill you on your usage, Ethereum comes with a cost. So every time you're modifying the blockchain, you'll have to pay a certain price, a very small price called the gas. Now, gas has its own unit called Gwei, and it is measured directly of the amount of computation that you have to perform when you're running that smart contract. So each code will have a certain set of instructions that needs to be executed, and how much ever the length or the intensity of that computation, that is the amount of price you have to pay for the Ethereum. So the way that we can do this is by something called smart contracts. So smart contracts are nothing but just special programs that can be put on Ethereum to do a certain task. And this is what enables us to make code that is deployed and performs the exact way it does. And what Ethereum uses for building these smart contracts is called Solidity. So Solidity is a programming language which was specifically built to program on blockchain. A lot of blockchains are using EVM and Solidity. So most of them are compatible except for some which are using like Rust or other programming languages. but Solidity is the most programming language out there. And if you want to get into blockchain, definitely pick it up. It's really simple. It's almost like JavaScript if you're familiar. So some tools that will help us build this app that we are about to build. So Truffle is a framework. Basically, it's a set of tools that will help us to manage our Ethereum projects. It has a nice command line tool which helps us get started, compile things, and all of that. And Ganache is a local test blockchain. So deploying directly on the Ethereum will cost us some money, right? Because it has to, like I said, it costs gas to deploy in the mainnet. So to test out our applications, and we won't even know if our application works right. So to test out our application, there are testing blockchains which you can have locally on your machine, or there is also live test nets which you can deploy to. So for this purpose, we'll be using Ganache, which is a local blockchain which you can run on your own computer and test out your smart contract if it's working as intended or not. So let's dive right into the code and let's check out how we can integrate this with blockchain. Okay, so I have a Flutter project ready here, and I have a few things added to it as well just to help us cut out the extra coding. So the first thing you can do is install Truffle using npm. So this is what the command will be, and once you're done, you should have the Truffle CLI, and just type Truffle, and you can access the Truffle CLI, and you can see all the commands that are present in Truffle. So you see it gives us a lot of options to interact with the blockchain or deploy to it, right? So the next thing you would want to do to initialize your smart contracts or your smart contract project is do truffle init. And once you do this, it will create this folder structure, and it will create some certain files that will help you in managing your project. So I've already created it, and you can see there are certain folders here called contracts, migrations, test, and truffle config. So truffle config is the most important configuration file, just like how Flutter uses a YAML file, just like that truffle config is a configuration file for truffle. So here I've mentioned a few things which I'll just go into in a while. So before that, let us just go through how we can how we can code Solidity, and let me just show you a few basic syntax and also what the app we are going to do. So I have a simple file here called example.sol. So this is how Solidity files look like. So they have an extension .sol, and you can name your file whatever you want. And there's also one more file here called migrations. This is what Truffle uses to identify who is the person who deployed the contract and just manage some of the things. So you don't need to pay attention to this, but this is where we will write our code, our smart contract to act, right? So the first line, starting line of every Solidity program should contain a keyword called pragma solidity. So this is what specifies the compiler that this particular file should use. And let's just define a contract. A contract is just like a class in any other language, but it specifically means that it's going to be a contract on the blockchain. So it starts with the keyword contract followed by the contract name. And then just let's make a simple variable so that we can mutate it later. So this is how you declare variables in Solidity. They support all basic types such as string, uint, and you can also specify the number of bytes that will be used, like uint 256, and by default it's uint 256. And every variable will be global in Solidity because it is stored in that particular contract. So you won't there are no such things as like storing it in something else. It will be like globally declared inside this contract. And let's make a function that will like set this name from our application. So what we are doing is we are going to type a name in our application, and this function will change this name hello flutter to whatever we type. So this is how you make a function in Solidity. So you write it with the keyword function, and you'll have to put public, and this has a certain implication. Public means that you can call this function from outside of the contract, which is what we want to do. There's also private, which you can call only within the contract. And also we have so yeah, we just set the name, and this is how mutating data works like in Solidity. And then let's just also make a function to get that name. So we have get name here, and you can see for a function that returns something, we'll have to add a few more things that returns string and memory. So these have a few implications. a view in, like I said, in Solidity, the money that will cost you to deploy a contract is directly proportional to the amount of computation it has to do. So by specifying view, we are telling Ethereum that this is just a view function, and we don't have to pay money to just read data. We only have to pay money to write data. So if you specify view, that will not have to pay money to just read this data, read the data which is named. And also in Solidity, there are two types of memories. One is storage memory, and another one is memory, this keyword. So this name here is a storage reference because it is stored permanently in the blockchain, whereas this is just a parameter that is temporarily being stored while this function executes. So we always have to mention this memory keyword in order to execute within functions where we are not actually permanently storing data to the blockchain. So that's it. Our contract is ready. So let's just delete these to show you in full. And let's just open our Ganache blockchain. So this will run a server on my computer, which is like a blockchain server. So we'll be able to deploy our contract to that blockchain. So once you open Ganache, you should see a UI similar to this, where you will have a list of all public keys, and you'll have like 10 accounts which you can test with. And also you can see all the status of this particular blockchain. It currently has 0 blocks. It's a completely new blockchain, and it has no blocks, no transactions, and no contracts, nothing, right? So what I have to do right now is, since my server is running, and you can see in truffle config that I have mentioned the network ID. So that Ganache server is currently running on this address and this port 7545. And that's why I've mentioned this, so that the truffle knows where to put that contract. And this is also an important part. So this is called ABI, known as the application binary interface, which will help us help our front end interact with the available contract or the available functions available in the contract. So we have to specify this build directory. We can put it anywhere we want. I'll just put it into the root, so it's easy for Flutter to pick it up. And then we also have a few other options which will optimize the code according to what options you give here. So the next thing we need to do is truffle migrate. You can also compile and migrate it, but truffle migrate directly does that thing. So doing truffle migrate will compile our contracts, and it will put it on the blockchain. And you'll be able to see all the details of the transaction that is happening. You can see it shows compiling your contracts, the network name, and it will also show you how much it costed. So it costed this much to deploy a contract. Right, so that's it. Our contract must be deployed, and you should be able to see it that there are currently 4 blocks which were mined, and the transaction was finally added. And you can also see what the what type of contract it was. Like, it was a contract creation, and it was called. So let's dive into Flutter now to integrate our contract with our front end. So I'll go to lib directly. So since I'll be showing like 2 demos, I'll be putting some of the common things in one file so that we don't have to duplicate code. So I just put it in this root.file, file, a few things which we'll need to connect to the blockchain and make read and write calls. So first thing we'll need is a dependency called web3 dart. So you can see I've added web3 dart here. So this is a wrapper around web3.js, which is a JavaScript implementation, which will help us make calls to our blockchain. So let's go to that, and we have already imported web3.dart and HTTP. So let's just declare our variables. First is HTTP client, and we need a web3 client. And then we need the RPC URL, which is the URL of the Ganache server running. And then let's make this initial setup. So you'll see that this should be called at the time when our app starts, so that all the connections are made. So here I'm using HTTP client to connect the web3 client with the URL and the HTTP client. So this ETH client is the web3 client instance. And we need 2 things to access our contract now. First, we need the user credentials, because as I told that you'll have to pay money to every transaction you do, which is a write transaction. So every time when I'm change the name on the contract, I'll have to pay some certain amount. And right now you can see that there are 10 user accounts here, and all of them. So I deployed and it lost like 0.01 Ether. So if I write more of it, you can take this private key. So if I do more transactions, it will decrease. So we need the credentials and we need the deployed contract instance, right? So let's just define all of those variables, and the private key is this. So we have the private key, we have credentials, which is the user credentials, and also the Ethereum address, which is like the user address again. And we also need the instance of the API and contract address. Now let's just write those methods. Get credentials, and the other one was get deployed contract, right? Yeah. So what I'm doing here is I'm just getting the credentials of that particular user from his private key, and you can see here I'm extracting the exact address of that user, which is his public key. And then I also have the get deployed contract. So this is where I'm fetching the exact contract from that API which was generated. So you can see there's example these APIs generated. So I'm getting that contract instance. First I'm getting the address, later I'll get the instance. So now I'll know where that contract is exactly deployed. And then I'll just write a few utility functions for reading and writing contracts. So first thing we need is the contract function. What contract function do we actually need to read? So in our case, if we take a look, it was get name and set name, I believe. Yeah. So these are the two functions that we need to interact with. So we have function name, function arguments. So in case of set name, it takes argument name and then the deployed contract instance itself. And all we have to do is do each client, which is the web3 client dot call contract function and params. And you'll have the result, whatever Ethereum returns. And then we also write a function to make write calls. So in case of write calls, you see it's a bit different. So a write call is it's not like a post request, it's actually a transaction. So we have to do send transaction credentials, meaning we are giving access to our account, and then we have to call it contract. So that should be it for what we need, the part of the Ethereum code that we need to deploy this contract. Yeah. Okay. So let's just head to the example.art and let me just show you what I've done here. So we need a few more things. One was the contract instance, which I didn't declare globally in that because I have a few different contracts. And second is the function names that we'll be interacting with. So for this particular contract, I need the contract instance and the get name and set name. These are the two functions that I need. And Web3 client package gives us easily wrapped classes to interact with all of these. So it's called a deployed contract, and this is called a contract function. So then to get that name, I'm just writing this read contract, which I declared earlier, and passing that get name. The argument is 0 because I don't have to get any write any arguments, and then the contract instance itself, and then I'm just doing set state to the name variable I have in my state here. And then I'm also doing the get contract functions because once I've declared these contract variables, I have to make them that instance by calling contract.function and the name of the function that we did, and from the API. So then I have just the UI code. So let's just run it and check out how it looks. So I just have like a simple widget here, a text box and a text field and a container showing the name, the text that we did. So if you can see here, the initial name that we put in this example.sol is hello Flutter. So this is what we should see once the app opens up. That means that it successfully read data from the blockchain and showing on our UI. So just wait for it to build. Until then, let me just show this Ganesh UI and how things work. So till now we have like 4 blocks, like I mentioned, and you can see its transaction and all the details of the transaction. And here you can see the transaction hash and which address it was. So this is the user address, public key, and this is the contract address. So it was deployed from the user to the contract. That's what it means. And Solidity can also have events, meaning that you can listen to events just like a stream. Once you do a certain action, Solidity can emit events and you can listen to them. So that has a different syntax. You can use it with the keyword event. and you can listen to events. So I won't be covering that, but you can definitely check it out. Okay, so you can see hello Flutter here, which means that it's successfully loaded from the contract. And now what I can do is I can change this, meaning that I'll be making a transaction to the blockchain saying hello Geekle. Once I change, so the transaction should be done. Let me just refresh it. And you can see it has been successfully done. And you can also verify this transaction on the Ganesh GUI. Now you can see it has 5 blocks, meaning that I made one transaction. And I can just make another transaction to turn it back to hello Flutter Global Summit. You can see it changed. So our app is working. That's good news. So let's just see a bit more complex code, and let's just go a bit more depth into how we can actually build a real world application, since it was just a very simple example, right? So let's take a look at IPFS. So IPFS is just like somewhat like on a basis of a torrent technology, if you're familiar with it. So it stands for Interplanetary File System. It works somewhat like a blockchain, meaning it's decentralized in nature, but it's a storage solution rather than a database. So blockchain is more like a database, and IPFS is like cloud storage. And why I'm telling you this is because IPFS is being used a lot with blockchain, especially to store NFTs and collectibles. IPFS is the go-to technology. And if you have any kind of storage needs, you can definitely use IPFS for those needs. And how it works is that you can either participate in this. So each content you store will be distributed and stored in different nodes on the network. So unlike the traditional, unlike how we use in centralized services, we have to know where the location of a particular image is, right? So we have to know the entire URL of the image, but IPFS just cares about what the content is. So it doesn't ask you to tell you where the content is, but it asks you what the content is. And that content is identified by a unique hash. And this is how it's stored in a distributed hash table, where it stores the IP of a particular node that contains that content and the content ID. So anytime you search for a particular content ID, it will just search in its peer nodes and check if they all have the content and then retrieve them back. And in case there are multiple peer nodes that have this content, it can easily retrieve them all at once, making it a faster consumption tool. Right? So all of the nodes can serve data simultaneously, unlike it's a centralized service where you have to wait for the server to send you all the data. So this is how even torrent works on the same basis. So let's see how we can combine IPFS and blockchain to build a private file storage server. So I have another contract here. So let's just make another contract called fileupload.solve. So I'll be using a little bit more of syntax in here. So we have contract file upload, and then we have a struct file. So you can see that this is how you create a data structure in Solidity. So use the keyword struct, and you can create whatever type you want. And to store this particular file, we need two things: the name of the file and the file hash. So that's why I've created this struct to store them. And the next thing we need is an array of files. For this, it will be a single user, which will be me. So if you're making it for multiple users, then you'll have to store a mapping of users' public keys to the array of files that they own. So in this case, since it's a single user, I can just store a file array here. And then I'll just create a function to store the file. You can see it takes two parameters, name and file hash. And I'll just do files.push, just like in JavaScript, and the file and those two parameters. And it should write the file contents to that particular array. And then also write a function to read those files. So I return here, view returns file memory, which is again what I explained the importance. So we have a contract ready. Let's just put it in the contracts folder. And we also need this migrations, which I didn't tell about before. So you need this migrations file to tell Truffle to where your contract is and if you have to deploy it or not. So it's a simple file where you mention like this: var file upload equals artifacts.require file upload, and you just tell deploy file upload. So this tells Solidity that you have to deploy this contract on the blockchain. So if we see in our API, we have only two APIs. So now if I run truffle migrate again, it should migrate the new file upload contract to the blockchain. While that is running, let me just open up IPFS. So IPFS is a CLI and a desktop tool that you can use. It is just like Ganache, it just hosts a local server which you can use to store files, and you can also participate. If you want, you can host other people's files and participate in the network of this distributed protocol. Just initialize and load. Meanwhile, Truffle is compiling our contracts. Okay, laptop is trying to slow down. You can see the IPFS is running, and Truffle has deployed our contracts. So let's just go to the Dart side and try to combine these. So I made a simple IPFS wrapper here, which is just a few HTTP calls. So you can make HTTP calls to IPFS. So I'm just doing a call to add a file here using the HTTP library, using a multi-part request. And I'm also doing a method to get the file and download it into a local system, which we'll see in action just a bit. So now we have the same thing, the same code that we put in root.art. So this is the reason I put it in that, so we don't have to rewrite it. And we have the client, sorry, that is redundant. Yeah, so we have the same functions here. One is initial setup, which is right here, I believe, or the one that we declared in root.dart. And then we have to get the contract functions, which is in this case, the store file and get file, right? Then I'm just doing the same thing which I did in the other app, which is just read the contract, get the result, which is a list of files. So I just take the index at that file, and then add file. I take the first, I put it in IPFS. So IPFS will give me a hash. Then I take the file name and hash and write that to the contract, and I set the file to null. Okay. So this is just all image picker code where I pick a file from the directory and do all that. So this is just UI code. So let's just see how it looks. So I have it right here. So you can see this is how it looks. I can select a file and I can upload it to IPFS, and I can write that data to the blockchain. So let me just select a file. So I have two things here. One is this mountains image. So it's selected now. So let me just upload it. It should store it in IPFS, and it should then write it to the blockchain. So once I upload it, okay, see some issue. Let me just reload my app. Yeah, I think now it should be able to, yeah, it's working. So let me just upload it. And you can see that now it is written to the blockchain. This is the hash of the file that was uploaded to IPFS. And this is the content in the blockchain, which contains both the file name and the hash. And I can even also download it. And you can also verify this transaction on the blockchain. If you will see that there was a recent call. This is showing the address here. Okay, if I connected the contract, it would show the contract name, but this is the contract address which we are using to. So we made a call to read this data, right? And now let me just download it because I implemented that feature. So it should be downloaded in my file. Yeah, you can see this Flutter app has downloaded a file, and this is the hash of it. So you can also verify this in IPFS by taking this hash, going to IPFS and searching for that hash. Since it's stored locally, it should show up. Okay. Yeah, so you can see it's stored locally, and it will open up this where the file is stored in this local host 8080. Okay, so that was pretty much it. This is how you can combine blockchain and application. Let me just cover a few more things in the slides. Okay. So what are we trying to solve here, and what is the main advantage? So we are going to transition in the future from how apps are currently built around data, from a data-centric app to user-centric app, in that the user will be able to tell and like decide where his data needs to go and how protected his data is. And there'll be more security because blockchains can't be easily hacked, unlike regular servers. So we'll be solving a major crisis, data crisis that has been happening over many years. Although blockchain has a lot of benefit, it also has some limitations or disadvantages. One such thing is called the blockchain trichotomy, which simply states that a blockchain can only have two of these and not all three. So if a blockchain is decentralized and secure, it won't be able to scale. Or if it's decentralized and scalable, it won't be secure. But a lot of new blockchains are overcoming this through different consensus algorithms. But Ethereum faces the same problem where it is decentralized and secure and it's not scalable, because of which transactions are taking a few minutes, over 5 minutes now, and even the cost of each transaction is going up to be more than like $100. And what spaces should you look out for? Blockchain is definitely going to come into every space, and these are some of the few. So DeFi is already very booming, and you can see everybody buying cryptocurrencies and holding them. And also we have healthcare. So the problem with healthcare is that each hospital will try to not hold their they all have a different set of rules and different types of data formats. So a patient will struggle when he switches from one hospital to another. So storing all patient history or his illness history in one single blockchain will have a single source of truth, and anything that needs authenticity verification and shouldn't be forged, like government services, should be stored on a blockchain. And this is how blockchain will revolutionize how data is stored and accessed in the future. And these are all other spaces you can definitely Google about. So if you want to get into blockchain, definitely these are the primary resources. Ethereum.org has everything you need to know about blockchain and Ethereum. If you want to pick up Solidity, then go to Crypto Zombies. And then some YouTube channels that I would recommend to learn more about this is DApp University, Finematics, and Simply Explained. And thank you.